I am Muhammad Akram. Today we are going to start our second lecture on operating system course. Before to start this lecture, just we will take a quick overview of our first lecture. In first lecture, we have seen what is operating system. Operating system, we have seen that operating system is which provide the interface between hardware and its user. And also the operating system, we have seen that it is responsible to manage, to coordinate the different activities and sharing of the computer resources. And at the end we have seen that it provides the basis for application program that we are going to install on our system. So these are the three main duties or responsibilities of operating system or functionalities of the operating system. Then we have seen the computer system structure. In structure we have said that there are the four main components in this structure: hardware, operating system, application program and user. As it is shown in the figure, that first layer, that is the computer hardware, then we have operating system, then system and application programs, and there are many application programs that we can install. For example, compiler, assembler, text editor, database system, word processors, and many things we can install on our system. But the important thing is we must need operating system before to install any application program. Then the last layer is the number of the users, okay, those who are accessing. There are the four components, that hardware, operating system, application program and users. Then we have seen the kernel. When we said that this is a basic component of an operating system, and what is the responsibility of kernel? It provides the bridge between application program and the data processing done at the hardware level. So it means there is a link between the hardware and software of the computer. Then who is going to make this link? This is the kernel. And this figure shows clearly that there is an application program, there are some hardware like CPU, memory, devices, and in between we have kernel. Then we have seen the bootstrap. What is the bootstrap program? That is also a very small application, and the first program that start is execution when we power up computer or we reboot our computer, that is bootstrap. And bootstrap has two basic purpose, that is, first is to initialize the aspect of operating system and then to load operating system kernel and start execution. Then next we have seen the what is interrupt, and we have seen the interrupt is an asynchronous signal. And why we need interrupt? Because it indicates the need of attention, that if somebody need attention, he will generate some interrupt. So in computer there is also some interrupts that are generated to get the attention. And we have four main type of interrupt, that is maskable interrupt, non-maskable interrupt, interprocessor interrupt and software interrupt. Maskable interrupt and non-maskable interrupt both are hardware interrupt, but the difference is that we can ignore maskable interrupt, but non-maskable interrupt we are not able to ignore. Then we have interprocessor interrupt. This is also a type of special case of interrupt that is generated by one processor to interrupt to another processor. This is also hardware interrupt, but this only between processors. If one processor want to communicate with other processor, he will generate one interrupt, and that is called interprocessor interrupt. And then we have software interrupt at the end, that is interrupt generated within a processor by executing the instruction. So software interrupt are often used to implement system calls. So software is interrupting or generating some interrupt. So this was our first lecture. So today we are going to start our second lecture, that is the continuation of first one. That first of all, this lecture also based on the first course learning outcome, that is recognize operating system history, services, application and types. Okay, now we will start that random access memory or RAM. What is random access memory or RAM? A RAM is type of computer memory that can be accessed randomly. So we can access this randomly. This may be that is any byte of memory can be accessed without touching the preceding byte. So in computer we must need this memory, random access memory or RAM. Without this it's not possible that we can execute the program. Here you can see this is the your memory that is going to install in this computer. Here you can see this is we are going to install in the computer motherboard. So computers the programs that we want to execute must be in main memory. If we want to execute the computer program must be in main memory to be executed. So main memory is the so we will see that we have some secondary storage devices like hard disk, but whenever if we want to execute any program, that program must be in main memory, otherwise we are not able to execute that program. Okay, so a type of RAM. How many type of RAM that exist nowadays? There are two different type of RAMs that are available in market. First one is the DRAM and second one is SRAM. DRAM is the abbreviation of dynamic random access memory and SRAM is static random access memory. So these two different type of RAM have differ in the technology. The technology is different, and they use the technology because what is the purpose of RAM? That is to store data, to hold data, and the technology that they are using that is different. But commonly we are using DRAM in our laptop, in our desktop system, in our home, in lab, in most of the time we are using only DRAM memory. So there are some differences that between SRAM and DRAM, that in term of speed SRAM is faster than DRAM. Why this is faster? Because there is a concept of static and dynamic. That dynamic RAM, DRAM need to be refreshed thousands of times per second, because this is dynamic. Every time it is changing, dynamically changing. So it need to be refreshed thousands of times per second, but SRAM does not need to be refreshed. So that is the reason that SRAM is faster than DRAM. So this is the first difference. In terms of speed, which RAM is the best one? SRAM. But at the other side, DRAM, SRAM is okay, it is faster, but it is not commonly used as DRAM. DRAM is commonly we are using everywhere. Why? Because DRAM is cheaper than SRAM. SRAM is much more expensive. Much more expensive. So this is the second thing, that in terms of money, DRAM is better than SRAM. In terms of speed, SRAM is better than DRAM. And at the end, both these type of RAM, one thing which is the common, that both are volatile, meaning they can lose their content when the power is turned off. So whenever you will switch off your computer, everything that is available in DRAM, it will be lost. So this is volatile, and there is a concept of volatile and non-volatile. So these two RAMs are volatile, mean there are temporary storage. The data, whatever we will store, it will be finished whenever you power off your computer. So what we have seen, the RAM is a type of computer memory that can be accessed randomly. Okay, so if we want to execute any program, the program must be in RAM. And then we have seen the type of RAM, and there are two different type of RAM, SRAM and DRAM, and they have different technology to store data, and there are some differences because SRAM is faster than DRAM and DRAM is cheaper than SRAM, and both are volatile. Okay, we have another type of memory that is called ROM, ROM, read-only memory. Read-only memory, as its name shows, that we can only read this. Read-only memory is a class of storage medium. We are going to store some data in computer or other electronic devices. We have this type of chip. As you can see here, that this is ROM, ROM, read-only memory. Data stored in ROM can only be modified slowly, with difficulty, or not at all. It's not very easy that ordinary programmer that he can modify data, he can delete data. No. For this you need some expertise, and it's very difficult, and normally this ROM is used to distribute the firmware. We are the firmware. What is firmware? Software that is very closely tied to specific hardware and unlikely to need frequent change updates. Because these softwares, there are some software that are only for some hardware that closely tied to the hardware, and we don't need to update again and again. So these type of things, this comes from companies. So these type of RAMs, read-only memory is also a storage medium, but it's not very easy to modify or to update the data. Okay. Now compute system architecture. In compute system we have two different type of architecture. The first one is single processor system. As its name shows, there is only one processor, not more than one processor. There is on a single processor system, there is a one main CPU capable of executing general purpose instruction set. So we have written many programs, and how many processor we have in our system? Only one. If there is only one processor, then we can say that this system is single processor system. As you see in this figure, that we have CPU core only one, then we have operating system, then we have many process like word processors, email, web browser, antivirus, and there is only one CPU that is available to execute all the process. So we have two type of architectures. One is single processor and the second one is multiprocessor, mean more than one. In multiprocessor system, the number of processors will be two or more, and they are in close communication sharing the computer bus, sometime the clock, memory, peripheral devices, as you can see here, that CPU 1, 2 and so on, CPU n. It depends that our system is dual core, quad core, i3, i5, currently available i7. So multiprocessor system, they share the RAM and system bus. So RAM that we have seen read-only memory, they are sharing. Okay, so in computer system architecture, what we have discussed, that we have two type of systems, single processor and multiprocessor system. So in single processor system, there is only one main CPU, and that is responsible for executing all the general purpose instruction set. In multiprocessor system, there are two or more processors, but they are in close communication. They are communicating with each other and sharing the computer bus, sometimes clock, memory, and peripheral devices. So they are sharing all the resources, computer resources, and they are in close communication system. Nowadays, most of the systems that we are using, that are multiprocessor system. Okay, we have seen the difference. There are two different type of architecture is available, single and multi. But why we use multi-processor system? There are some advantages. There are some advantages. That's why we prefer multi-processor system. So what is these? First one is increased throughput. Then we have economy of scale. Then increased reliability. So these are the three main advantages. There are many other advantages, but there are the three main advantages of multiprocessor system on single processor system. So we will see one by one what is increased throughput, economy of scale, and increased reliability. So increased throughput mean if by increasing the number of processor we can expect to get more work done in less time. So if number of processors are more, it means the work will be finished quickly. The work will be finished quickly. Let's suppose if we make here one division, that we have two type of system. First one is okay. If I make here, just to give you one example, that there is one system 1, and then we have system 2. In system 1 there is only CPU 1, but in system 2 we have CPU 1 and CPU 2. So one task is given to this system 1 task 1, we say this is the task, and then we have given same task 1 to this system 2, and we assume that if suppose that this system 1 is completing this task in 4 days, or I say 4 minutes. So how much time this system 2 will take? Because CPU, he has one CPU, he has 2 CPU. Okay, and it means clearly it shows that because number of CPUs are more, so it will finish that work in 2 minutes. What do you think? That here we have only one CPU, and here we have more than one CPU, 2 CPUs. Speed of, assume that we say the speed of this CPU is 2 gigahertz, and speed of this CPU is 2 gigahertz and 2 gigahertz. Now see this one. The system 2, it has only one CPU, but system 2 has two. System 1 has only one CPU, 2 gigahertz speed, and system 2 it has 2 CPUs, 2 processors with 2 gigahertz and 2 gigahertz. So if this system is finishing his work in 4 minutes, it means the system 2 will finish his work in 2 minutes, because the number of processors are increased. Okay, if I give you another example, that suppose I make 2 groups of students. One group contain only 2 students and one group contain 4 students, and I give the same assignment to both the groups. So if first group 1 is finishing his assignment in 4 days, so it means the second group he can finish his work in 2 days, because numbers are increased. So same thing is here. In increased throughput, that number of processors are increased, and number of processors increased mean work will be finished more quickly, more work done in less time. So this is our first advantage. So second one is the economy of scale. Economy of scale. So it's for sure that multiprocessor system can cost less than the equivalent multiple single processor system. Because why this? because they share peripheral devices, mass storage and power supplies. So if we purchase one system that have more than one processor, and it means all these processors, they are sharing these devices, peripheral devices, storage, our hard disk, keyboard, mouse, system bus and many things they are sharing. But if we purchase the equivalent single processor system, then each processor have his separate memory, separate hard disk, separate keyboard, separate monitor, separate mouse and these things. So if I show you this, let's suppose again, if you see these two systems, system 1, system 2, the speed of this system is 2 gigahertz, but speed of this system, system 2 is 2 plus 2, 4 gigahertz. And if the cost for this system is suppose 2000 real, and if I want equivalent speed, mean 4 gigahertz this, so it means I need to purchase another system, because single processor system, this is single processor, this is multiprocessor. So 2 gigahertz, maybe this system is 1500 plus 1500 another, 3000 real. So it means multiprocessor system, in multiprocessor system we have advantage, that is this is economical, that we can save money from using the multiprocessor system. Okay, so last one is increase reliability, because multiprocessor systems are more reliable than the single processor system. Why? Because the function, the work is distributed among the several processors. So if one of the processor is fail, then it will not halt the system, only little bit slow down the system. For example, if you see, this is one example, if we have 10 processors in one system and they are working, and maybe suppose one processor fail, then each of the remaining 9 processors can pick up a share of work or of the failed processor, thus entire system runs only 10% slower. So it means the remaining 9 processors, they will not stop, they will continue their work. Okay, so we have this third advantage, that increased reliability, that multiprocessor system, they are more reliable than single processor system. So we have seen 3 main advantages of multiprocessor system, that increase throughput, economy of scale and increase reliability. Okay, so next our topic is that multi-programming. Okay, multi again mean more than one program. So what is multi-programming? It is a technique which is used to utilize the maximum CPU time. So we don't want that our CPU become idle. We don't want to give rest to our processor. So multi-programming is a technique that to run multiple programs at the same time. That is, execute, as it is written, execute more than one program at a time, is called multi-programming. So this is a technique that we are using to make our CPU as busy as possible by running more than one program at a time. So how it will work, that let's suppose if you see this figure, that we have job 1, job 2, job 3, job 4, and we have operating system code also, operating system space. So we have one processor and 4 jobs, and now we will start suppose with job 1, and after some time this job is not completed, maybe he needs some device, some input from the keyboard. Now maybe user, he wastes some time, 1-2 seconds in giving input, but the system will not wait that for input, he will move to the job 2. He will jump to the job 2 and start execution of this one. So it is clearly explained here, the operating system picks and begin to execute one of the job in the memory. So this is job of operating system. to select one process and give to the processor for execution. Now we have some algorithms how we can select a process. So we will see in coming lectures there are some algorithms that we can use. Okay, here just that operating system will select one process and it will give to the processor to execute. But the job may have to wait for some task such as an IO operation to complete. Maybe that job is waiting. After maybe total time he need to execute is 5 seconds, but after 1 second he needs some IO operation. So what will happen? In multi-programming system, the operating system simply switch to another job and execute. He will jump. He will go back to the another, like here job 1. He is waiting for some IO device. He will not stop. The processor will not stop here. He will jump to another, maybe job 2 or job 3 or job 4, and he will start execution. When the job need to wait, the CPU switch to another job and so on. And maybe job 2, after job 1 we started job 2, and job 2 maybe he is waiting for something. He will not stop here. It will jump to another job and so on. In this way it will do. But eventually first job finish waiting and get the CPU back. Let's suppose job 1 his wait finish, that the device that he was willing he get. Now what will happen, that CPU will jump back to this job 1. Okay, switching. This is switching from one job to another job. As long as at least one need to execute, the CPU is never idle. So multiprogramming, the purpose of multiprogramming is to make our CPU busy. We don't want that our CPU do some rest. No, the purpose of our processor is to work. Okay, now this is very important, that in our system we always have dual mode operation, and this is very important in our system, that because there are two things that are working all the time, that one is the user of the computer and another is operating system. Okay, so here that in order to ensure the proper execution of operating system, the purpose of dual mode is that ensure the proper execution of operating system. We must be able to distinguish between execution of operating system code and user defined code, because we are also writing some code. Okay, so we have two modes, that is first one is kernel mode and second one is user mode. Kernel mode also called supervisor mode, system mode or privilege mode. Okay, so whenever operating system code is running, it means the system is in kernel mode, and whenever user code is running, it means the system is in user mode. So if as a user, if I am writing some code in C, in Java or in any language, so it means I am in user mode. Okay, so we need two type of mode in our system, kernel mode and user mode, and kernel mode also called supervisor mode, system mode or privilege mode. Okay, so next, why we need the kernel mode and user mode? Okay, whenever we start our computer at system boot time, the hardware always start in kernel mode. Hardware start in kernel mode. You have seen that whenever we start our system, it take few seconds, maybe 30 seconds, 40 seconds, or sometime maybe 1 minute, and it means that it is starting, initializing everything. So system start at hardware, start the hardware in kernel mode. At that time system is in kernel mode, we are not able to do anything. Okay, then at the last operating system is loaded and start user applications in user mode. Okay, so first system will be in kernel mode, hardware start, and then it load operating system, and then system is started in user mode. Okay, whenever an interrupt occur, whenever an interrupt occurs, the hardware switch from user to kernel mode. Interrupt, again, we have 4 types of interrupt, we already have discussed. So interrupt to need to get the attention of for everything. So whenever an interrupt occurs, so we will see that we have some ways, okay, so to control this. So whenever an interrupt occurs, the hardware switch from user mode to kernel mode. And how it can be achieved? By just changing the mode bit to 0. If mode bit is 0, it means we are in kernel mode. Thus, whenever the operating system gains full control of computer, it is in kernel mode. So we have 2 modes, user and kernel. When operating system has full control of the system, it means this is kernel mode. Okay. Whenever user have control of the system, it means this is user mode. Okay. So how we can switch from user to kernel mode? So in next slide we will see one diagram that is clearly explaining that how we can switch from user to kernel mode and kernel to user mode. This is just by setting a mode bit. We have here one mode bit, and mode bit we will set, and we will move from user to kernel and kernel to user. Now if you see this diagram, that we have this area, this total area is user mode. This is user process, that user mode, and this area below, that is kernel mode. Suppose this is kernel mode. Now here user process executing, we are executing user process, and then we call the system call. It means no, we have to system call. Who can execute the system call? Operating system. So we will move from user to kernel mode, and here you can see clearly that mode bit is equal to 0. Whenever we are in kernel mode, mode bit always will be 0. Okay, so the operation of moving from user mode to kernel mode, this is called trap. Okay, trap, to move from user to kernel mode. Okay, now here the control is with operating system. Whenever we are in kernel mode, who is controlling the system? Operating system. Okay, now if we want to go back to the user mode, then we need to set the mode bit is equal to 1. Okay, and the operation, the process of moving from kernel to user, it is called return. Okay, so 2 things very important, mode bit and operation. That whenever we are moving from user mode to kernel mode, we need to set mode bit 0, and this is called trap. And whenever we are moving from kernel to user, mode bit we need to set 1, and this process is called return. And here you can see that in user mode, mode bit is always equal to 1. In kernel mode, mode bit is always equal to 0. Okay, so this was our today's lecture. So just we will take one quick overview of our lecture, what we studied today. That we have seen first thing, RAM. So we said that RAM is a type of computer memory that can be accessed randomly. We can access this RAM, we can read data on the RAM, and whenever we want to execute any program, so that program must be in main memory or RAM to be executed. If we want to execute, it must be shifted from hard disk to RAM. Then we have seen we have 2 types of RAM, DRAM and SRAM, and the purpose is to store data, to hold the data, but they are different in technology to hold the data. And there are some comparison between SRAM and DRAM, and we are saying in terms of speed, SRAM is faster. In terms of money, DRAM is good, because SRAM is very expensive. And both these type of RAM are volatile, mean they can lose their contents. They will lose their contents whenever it is turned off. So we have seen then read-only memory, and we have seen that we can only read the information, but it's very difficult to change that information. And mainly it is used to distribute the firmware. That is some software, specific software related to a hardware, some specific hardware. So this is used to distribute the firmware. And we have seen the computer system architecture. In architecture we have seen we have single processor system and multiprocessor system. In single processor system only one processor is working, and in single processor system we have two or more processor. They are sharing different resources and they are in close communication with each other. Then we have seen some advantages. We have seen there are three main advantages of multiprocessor system: increased throughput, economy of scale, and increased reliability. So next we have seen the multiprogramming. What is multiprogramming? To execute more than one program at the same time. This is called multiprogramming. And why we use multiprogramming, this technique? Because this technique is used to utilize maximum CPU time. We don't want that our CPU go and sleep. We want that we want to make our CPU busy. So to make CPU busy, we must have many programs in our memory to execute. Okay, so this concept is called multi-programming. Then there is, I given one example how it is working. Then at the end we have seen the dual mode operation. What is the dual mode operation? Dual mean two, that we can execute more than one program at the we have always two different type of modes, that is kernel mode and user mode. Okay, because we have two different type of code, user code and operating system code, the code that we are going to define and the operating system code. So we have seen that whenever we are starting our system, hardware always start in kernel mode, then operating system is loaded, then user applications are loaded in user mode. So we can switch from user mode to kernel mode. There is by setting the mode bit, and we have seen if the mode bit is 1, it means we are in user mode, and if the mode bit is 0, so it means we are in kernel mode. Okay, so the process of moving from user to kernel mode, this process is called trap, and moving from kernel mode to user mode, this process is called return. Okay, whenever operating system have full control of the system, we are here in kernel mode. When user have a control of system, we are here in user mode. Okay, so this was our second lecture. So if you have any question, you can ask me through email, or you can visit my office during my office hour. Thank you, and